It flew once, one single flight. And then the British government made sure almost nobody talked about it for decades. No combat deployment, no production order, no public announcement. The aircraft was quietly dismantled. The paperwork was buried in classified ministry files. And the engineers who built it were moved on to other projects without ceremony. Even today, most aviation historians pass over it in a single footnote, if they mention it at all. But that one flight changed what Britain knew about its own capabilities. And the reason it was buried tells you more about wartime politics and institutional fear than it does about aeronautical failure. By 1943, Britain was fighting a war on multiple fronts with an industrial base that was being systematically targeted by the Luftwaffe and strained by the demands of supplying campaigns in North Africa, the Atlantic, and the Pacific Theater simultaneously. The RAF's Fighter Command had successfully defended British airspace in 1940, but the men running Britain's Air Ministry understood something that public morale messaging obscured. The technological margin was narrowing. Germany's jet program, while not yet fully known in its scope to British intelligence, was generating fragmentary reports that caused serious concern. Intercepted communications, reconnaissance photography of unusual aircraft at Lechfeld and other Luftwaffe test bases, and debriefings of aircrew who reported seeing impossibly fast aircraft during operations over-occupied. Europe, all of it pointed toward a German breakthrough in propulsion technology that Britain could not yet match in operational terms. Frank Whittle had been developing his jet engine concept since the early 1930s. His W1 engine had powered the Gloster E.28, Britain's first jet aircraft, on its maiden flight from RAF Cranwell on May 15, 1941. That was a genuine milestone. But a single-engine experimental aircraft was not a weapon system, and the Air Ministry knew it. The question pressing on planners by 1943 was not whether jet propulsion worked. It was whether Britain could build something fast enough, armed enough, and reliable enough to field before Germany's own jets appeared over the English Channel. What happened next was one of the most technically ambitious and institutionally complicated aviation programs in distant British wartime history. It involved one of Britain's most gifted aircraft designers, an engine that pushed the boundary of what metallurgy and thermodynamics could sustain, and a test flight that produced results so unsettling for reasons both technical and political that the program was effectively suppressed before it could gather momentum. The aircraft was the Miles M52, and its story deserves to be told in full. The Miles Aircraft Company was not, by reputation, the kind of firm that built cutting-edge experimental fighters. Based at Woodley Airdrome near Reading in Berkshire, Miles had built its wartime reputation on training aircraft. The Miles Master Advanced Trainer was ubiquitous at RAF flying schools. Frederick George Miles and his wife Blossom Miles ran the company with a combination of engineering instinct and commercial pragmatism that had kept them solvent and productive while larger firms competed for fighter contracts. That reputation for being slightly outside the prestige hierarchy of British aviation is precisely why what happened in 1943 is so surprising. In late 1943, the Directorate of Scientific Research within the Air Ministry approached Miles Aircraft with a specification that was, speaked by any measure of the era, extraordinary. The requirement, which emerged from research being coordinated partly through the Royal Aircraft Establishment at Farnborough, called for an aircraft capable of reaching 1,000 miles per hour in level flight. In a world where no aircraft had yet broken 700 miles per hour in sustained level flight under any conditions, this was not an incremental development goal. It was a request to leap past every known boundary of aeronautical knowledge in one design exercise. The specification that framed the project was formally designated E.2443. The aircraft that Miles began designing in response would be designated the M52. And the man who led that design effort was a young engineer named Dennis Bancroft. Working under the technical direction of the Miles team with consultation from Ray Farnborough's aerodynamicists, what they collectively arrived at was a design philosophy that was, in hindsight, strikingly prescient. The 52 was to be a small, extremely compact aircraft, essentially a powered projectile with a pilot inside. The fuselage was designed in a near-perfect circular cross-section, sometimes described as a flying barrel, which minimized frontal area and therefore transonic drag. This was not an aesthetic choice. It was a calculated response to what RAE's theoretical work was suggesting about wave drag near the speed of sound. The wing design was equally radical, very thin, straight, with a sharp leading edge, specifically chosen to delay the onset of compressibility effects that plagued conventional wing profiles at high speed. The tailplane was an all-flying design, meaning the entire horizontal stabilizer moved as a control surface. Rather than relying on conventional elevators hinged to a fixed stabilizer. This was a crucial insight. Conventional elevators lost effectiveness dramatically as aircraft approached transonic speeds. An all-moving tail was the engineering answer. The engine chosen for the M52 was a development of the PowerJet's W2-700 turbojet, substantially modified by the addition of an afterburner, an augmented thrust system in which additional fuel was burned in the jet pipe downstream of the turbine to generate significantly higher thrust for brief periods. This configuration, which would become standard on supersonic fighters throughout the Cold War era, was in 1943 an extremely experimental concept. The augmented W2-700 installation was projected to push the M52 through the critical transonic regime and toward its target speed. None of this existed as proven hardware. Every element of the design was theoretical, extrapolated from wind tunnel data, thermodynamic calculations, and a degree of engineering courage that is difficult to appreciate unless you understand how little was known about transonic flight in 1943. The compressibility problem, the dramatic and unpredictable changes in airflow behavior as aircraft approached the speed of sound, had already killed pilots. Hawker Typhoons and Supermarine Spitfires in steep dives had encountered violent control reversals and structural loads that occasionally destroyed them before pilots could recover. What caused these phenomena was understood in principle, but managing them in a purpose-designed aircraft had never been attempted. Construction of the M52 prototype at Woodley proceeded through 1944 under conditions of significant secrecy. The aircraft's existence was restricted on a need-to-know basis within the Air Ministry. Miles personnel working on the project were not permitted to discuss it externally. The design evolved through multiple revisions as Ray Farnborough's ongoing research refined the aerodynamic picture. And correspondence between Miles, engineers, and the ministry's scientific staff shows a project under constant intellectual pressure, solving problems in real time while building hardware to answer questions that theory alone could not resolve. By early 1945, the M52 prototype was approaching completion. The aircraft's dimensions were small by fighter standards, roughly 30 feet in length, with a wingspan of approximately 27 feet. The cockpit was enclosed within a bullet-shaped nose cone that would separate from the aircraft in emergency. The entire forward section acting as an escape capsule in an era before ejection seats had been perfected. This was not a detail that reassured test pilots. The man who would have flown the M52 in its high-speed evaluation program was Flight Lieutenant Eric Brown, one of the most accomplished and fearless test pilots in British aviation history. Brown had already accumulated experience on an extraordinary range of captured German aircraft, Allied prototypes, and carrier-based designs, and his technical judgment was respected across the RAE and Fleet Air Arm Test establishment. His assignment to the M52 program indicated the seriousness with which the Air Ministry regarded the aircraft's potential. Then the war in Europe ended. Germany surrendered in May 1945, and within weeks, the strategic rationale that had driven the M52 program began to dissolve in the minds of certain ministry officials who were already thinking about budget reductions. Post-war restructuring, and the political optics of expensive experimental programs in an era of national exhaustion. There was also a parallel development that complicated matters considerably. In 1944, A technical exchange agreement had been reached between Britain and the United States, under which Miles Aircraft shared detailed M52 design data, including the critical all-flying tail concept, the wing geometry, and the afterburner installation data with American researchers. The recipients included personnel connected to what would become Bell Aircraft's transonic research program. In October 1947, Captain Charles Yeager flew the Bell X-1 through the sound barrier at Muroc Dry Lake in California. The X-1 featured a thin-wing design and, critically, an all-flying horizontal stabilizer. The degree to which British M52 data directly influenced the X-1's design remains a subject of genuine historical dispute. But the design parallels are not coincidental in the view of many aviation historians. And the timing of the data transfer has been documented. Britain, meanwhile, cancelled the M52 in February 1946. The official reasoning cited the prohibitive risk to a human pilot in an aircraft attempting transonic flight, and advocated instead for pursuing the research through unmanned, rocket-powered scale models. This was not an unreasonable position. American and German researchers had also grappled with the question of whether a piloted aircraft was the right vehicle for initial transonic probing. But the abruptness of the cancellation and the manner in which it was handled left the Miles Company and its engineers bitterly frustrated. Frederick Miles wrote later that the cancellation felt less like a reasoned safety decision and more like a politically motivated withdrawal from a program that had become inconvenient. The aircraft was essentially complete. The engine installation was progressing. Eric Brown, who had been preparing for the test program, was reassigned. The prototype was not preserved. It was broken up. The unmanned model program that replaced it did eventually fly a rocket-powered M52 scale model in October 1948, achieving supersonic speed in a shallow dive, making it the first British vehicle of any kind to exceed the speed of sound. The irony was precise and painful. Britain had the knowledge, the hardware, and the pilot. It had cancelled the program 9 months before Yeager's flight made the achievement famous and American. What followed in the public record was decades of institutional silence. The M52 file remained classified. The Air Ministry did not publicize the program or acknowledge the design's sophistication. When post-war aviation journalists and historians began piecing together the story of Britain's jet development, the M52 occupied a conspicuous gap, mentioned rarely. Documented poorly in open sources, its significance either unknown or deliberately understated. It was not until the gradual declassification of wartime air ministry files in the 1990s and into the 21st century that the full picture of what Miles had built and what had been shared with the Americans became accessible to researchers. Dennis Bancroft, who lived to see some of this recognition, gave interviews in his later years in which he was measured but clearly still affected by what had happened. He was careful not to overstate what the M52 would have achieved. He acknowledged the genuine unknowns, but he made clear that the aircraft had been real, that the engineering had been sound by the standards of available knowledge, and that the decision to cancel had not been driven by technical failure. There was no crash. There was no catastrophic test flight that revealed a fatal flaw. The aircraft that the title of this story suggests was buried after one test flight is, in the most honest telling, a slight dramatization of a more complicated truth. The M52 was buried before its test flights, which is, in some ways, a more troubling fact. A program that had reached the threshold of a genuine historical achievement was stopped by a bureaucratic decision made in the gray, administrative aftermath of a victorious but exhausted war. What Britain lost in February 1946 was not just one aircraft. It was the claim to a milestone that would instead belong to a different country, flying a different aircraft, 9 months later over a dry lake bed in the California desert. Whether the M52 would have succeeded, whether Eric Brown would have survived the attempt, whether the engineering solutions would have held together under the real aerodynamic forces of transonic flight, none of those questions were ever answered. The aircraft was gone before anyone could find out. Some secrets are buried because they failed. This one was buried before it had the chance to prove it wouldn't. The M-52 is one of several wartime aviation programs that disappeared into government files and emerged only decades later, quietly, without the recognition their engineers deserved. There are others, programs canceled, suppressed, or simply forgotten in the fog of institutional memory. If recovering those buried chapters of aviation history is something worth your time, consider subscribing. The record still has gaps worth filling.